Good morning, my trailblazers. Today, we are gonna be talking about one paper. So I switched the format a little bit to focusing on one paper and going a little deeper. We're going to be working with the paper, with the abstract, and then we have our AI created presentation, and I'm going to be perfecting it. So I hope this new format is going to be good for you.
Learn about the newest digital pathology trends in science and industry, meet the most interesting people in the niche, and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
I'm Dr. Alex Zhurov. I'm a veterinary pathologist working in the digital pathology space for over a decade and teaching you about digital pathology because I believe patients have the right to fast diagnosis, and the gateway to fast diagnosis is digital pathology. So let's dive into our paper today. DALPHIN. Let's call it DALPHIN, Benchmarking Digital Pathology AI Copilots Against Pathologists on an Open Multicentric Dataset. This is our paper today. It is a preprint from Archive. And why did I take a preprint? So a friend of mine and a former colleague, Thibaut Jewi, posted this funny thing on LinkedIn where he was sitting at a table saying the real science is not published in high impact factor journals anymore. It's published on the preprints, and prove me wrong. And he was sitting at this table, and I'm like, let me think about it, because I was like, I don't want to read any preprints because it's not peer reviewed. But then, of course, the peer review takes time, and there's a lot of other things involved in that. So I thought, let's take a preprint. And also, I know a few of the authors. I know Diana Montezuma. I think we have Francesco Ciampi, who I'm waiting for him to join me on the podcast. Oh, there is a Polish-sounding name, Mateusz Maniewski and Adam Kowalewski. Anyway, so I know a few of them, and it's an interesting paper. Abstract tells us that the foundation models with visual question answering capabilities for digital pathology are emerging. Yes. So a foundation model with visual capabilities would be a ChatGPT, and this is one of the ones that they were testing here. Such unprecedented technology requires independent benchmarking to assess its potential in assisting pathologists in routine diagnostics. And pathologists are already checking this, pasting images and checking, okay, am I going to be replaced or not? And that was another post on LinkedIn by the OG of digital pathology communication, Dr. Keith Kaplan, where he was playing with ChatGPT for diagnostics. And he stated that, no, we're not going to be replaced yet. So DALPHIN is the first multicentric open benchmark for pathology AI copilots, comprising 1,236 images from 300 cases, and they are spanning 130 rare to common diagnoses, 6 countries, and 14 subspecialties. So I want to highlight this like in a different color anyway, but like 6 countries and 14 subspecialties. Congratulations. I hope it shows up in a super high impact factor journal soon, because coordinating, I'm always impressed when authors, like, look how many authors are here. A lot. Coordinating this effort is like a medal on its own. When I have to write a paper with like 3 or 5 co-authors, I'm like overwhelmed with how much logistics there is, which there is none. Like, you know, they review, they help you, they write their papers, their part. But here, respect. Anyway, so DALPHIN designed and the DALPHIN design and data sets are introduced alongside a human performance benchmark of 31 pathologists from 10 countries. Like, another thing, 31 pathologists, like 31, gather and coordinate 31. Amazing. Congratulations. 10 countries, and they report the results of 2 general purpose ChatGPT Gemini 2.5 Pro, and one pathology-specific copilot, PathChat Plus, which is fantastic that they included a pathology-specific one, for sequential and independent answer generation. So they observed that no statistically significant difference from expert level performance in 4 of 6 tasks for PathChat, 2 out of 6 for Gemini, and I'm sorry GPT, but just 1 out of 6. So GPT didn't do so great. I have a presentation that is co-created with AI, and of course changing what I want to share is a challenge. But I can do it. I can do it, my trailblazers. So, before you try to use ChatGPT or Gemini or even PathChat for your pathology diagnostic tasks, let's have a look what happened. What was the result of this ultimate diagnostic stress test? Benchmarking AI copilots against human pathologists in clinical reality. And as we said, 300 cases, amazing. So they address a lot of interesting data science points in this paper, and I highly recommend you actually read it or listen to it. But there is one core problem when you benchmark them, for benchmarking these models, that it's so-called data leakage and the illusion of genius. What do they mean by that? That models like Gemini and ChatGPT, they ingest a lot of data, right? The entire public internet, and standard benchmarks fail because the AI has likely already memorized the answer key. So if it was something online where there was questions and answers, it already learned it. So DALPHIN solves this via a sequestered and unscrapable testing vault. What do they mean? So the open pipeline, everything is here, is in the training data, including the test questions and the answers, and the chat is memorizing it. So basically like cheating because it memorized it. Whereas when we look at the DALPHIN way of training it, what they did, they sequestered the training data. So AI was training on sequestered data, and then ground truth data was made so-called unscrapable. What does that mean? That the AI model could not scrape it and train with it. So this is why they consider this a true evaluation. And also what they realized, that they wanted to simulate the human diagnostic workflow. What does the human diagnostic workflow look like? When a pathologist diagnoses, you look at low magnification first, and then you only go into the places that you, on low magnification, decided that are relevant, right? So here, for example, this particular place, it looks from far away that there is like some inflammatory stuff, and sure enough, these are all inflammatory cells. And their insight was that AI cannot rely on text alone, and they already use, well, the capabilities of the models are there because these are vision and text models, but it's not just text or just vision, it's the two. So it must synthesize macro architecture with micro details, and like a doctor does at a microscope. So in addition to text, right? And then it can produce text. So here is who was tested. Gemini 2.5 Pro. Do you use Gemini a lot? It comes with the Google subscription. I have access to it, but I have not used it so much. And maybe I should, because it definitely outperformed ChatGPT. Well, so it outperformed, it matched the non-expert, human non-expert in 2 out of 6 tasks, whereas GPT just 1. So, and then PathChat is pathology specific. So, here was who was being tested. Human pathologists, and they were resident, was the non-expert, and there was an expert, right? And what they found in this paper, and they checked how in general these models behaved. So they stated that, okay, Gemini was a generalist and the diagnostic baseline was open web, and there were a couple of rounds of testing. They tested how it handled ambiguity in round 3 and anchor bias vulnerability, and we're going to talk about what that is in round 4. There were just 4 rounds of testing. And ChatGPT, also generalist, trained on open web. PathChat is domain specialist. It's for pathology, PathChat. And it is multimodal pathology. This is the diagnostic baseline. Everything was tested. And then we had our human pathologists, which training paradigm is biological, experiential, years of tacit knowledge, and was also tested for ambiguity handling and anchor bias vulnerability in round 3 and 4 respectively. So round 1, I love it because in round 1, they tested basic orientation, which is how it recognizes tissue, which to me, it was like, that's easy. Like, you need to know it. Pathologist needs to know it. But I was also surprised how that this is a perishable skill once you specialize. And I was surprised because I'm a veterinary pathologist. So this is, and I work in ToxPath, in toxicologic pathology, where you always have to evaluate all the tissues of the animals that you're evaluating. So I need to recognize these tissues. I mean, I have it labeled, but you need to recognize the tissue. So it was a given for me that every pathologist in the world recognizes every tissue. That is not the case. And especially when you have highly specialized pathologists in human medicine, they did not recognize. So, oh my goodness, I forgot to put my earrings on. And my test was the earrings. I would show the earrings and ask, what tissue is it? And not everybody knew. So guess which tissue is it? And I'm going to tell you at the end of the live stream what it is on my earrings that I'm putting on right now. So anyway, they tested. And also I'm super happy about this tissue recognition challenge, or the necessity to train the skill, because we are also, by we, I mean Digital Pathology Plays team, so myself and my team supporting me in the background, we are hosting histology live streams where we teach how to recognize tissues, and we were supposed to do one in the tomorrow, but maybe it's going to be next week. We'll see. But it's on a regular basis. And one thing that I want to do is just basically have a bunch of tissues and have a session recognize the tissue with me. So if you're interested in that, let me know in the chat, then I can send you the link to that live stream. But here, human experts universally outscored all AIs on basic organ recognition. Even PathChat. I'm sorry, PathChat, you're domain specific, but the humans were better by 24.4%. So what was difficult? Difficult was something that has an amorphous logic, so-called soft tissue. And I'm like, what is soft tissue? Everything that is soft tissue. Kind of like, but in pathology, soft tissue is being referred to when you talk about muscle, connective tissue, tendons, and like the bone supporting structures. That's why you have the bone and soft tissue pathology. When I learned this term, I was like, why? Bone is hard and soft tissue is soft. Why do you put them all together? Because it's the musculoskeletal, also including fat tissue. So, soft tissue was not the strength of AI. Skin was okay because it has high structural logic. When you look, you have the keratin on top, the epidermis, connective tissue here in the dermis, and then subcutaneous tissue. But soft tissue is like a bunch of soft tissue. PathChat completely omitted tissue prediction for 41.5% of soft tissue cases, saying no residual normal tissue is recognizable. So, sorry, PathChat, you need to be trained additionally on soft tissue. And also, the performance varied wildly based on the structural predictability of the organ and representation in the training. And there was different representation of different tissues. Skin was good. Breast was relatively good. So the red ones were good. The gray ones were not that fantastic. Bone and soft tissue, gray. Hematopathology, not that great either. So now we are at round 2, right? Neoplasm detection and AI personalities. So at the beginning we had this like, oh, ChatGPT is generalist, Gemini is generalist. And my AI co-analyzer of papers, Notebook LM, classified them as one is an anxious student and the other one is the relaxed student. Anxious student overcalls everything. So Gemini was highly sensitive but had low specificity, jumps at shadows, catches real tumor but frequently misclassifies benign inflammation as neoplastic. So that's what Gemini is doing. Whereas ChatGPT is more relaxed. It's not calling everything. It's highly conservative, ignores shadows, but actively misses real existing neoplasms. So this is high specificity, but low recall. And the balanced resident is our expert gold. PathChat and human residents were here in the middle, where so they were what we want to strive for. We don't overcall, we don't undercall, we are just right. The expert gold. So, and what the authors of the paper say that without knowing your model's inherent calibration bias, a doctor cannot safely contextualize its advice. So the next time you try Gemini or ChatGPT, try to remember that, okay, Gemini was an overcaller, whereas ChatGPT was an undercaller. Next time, when I present, I need to bring all these LinkedIn posts that inspire me, like Keith Kaplan's and Thibault's posts about how I run the live stream. So, behavioral matrix, precision versus recall. So, what we want high precision and high recall. ChatGPT has kind of high precision, but the recall is very low, whereas Gemini has high recall, but the precision is pretty low. PathChat was the closest to our human resident. It approaches expert recall, but precision and specificity remain comparable only to non-expert human residents. So, interesting. PathChat is already at the level of a non-human expert. Obviously, we want higher level, but still, that's interesting. For this particular chart, we're going to move to a different screen because my AI didn't do a great job. Well, it did a great job showing like what we want to show, but the graph does not represent reality. So let me share the paper. We have here common cancers and rare cancers, and Gemini is blue, ChatGPT is this orange, and PathChat is red. Experts are in dark gray, non-experts are in less dark gray, clear gray. So this is expert reference and non-expert reference, and common cancers. So expert, PathChat was like really nice for common cancers. But for rare cancers, it missed the mark, right? So these are the experts, but for non-experts, it actually was on par with the non-expert. So what do we mean by rare cancers? It is less than 6 per 100,000 cases. And so the promise, I'm going to go back to the presentation. I'm just going to ignore our charts here. Because the promise that everybody is talking about, AI is marketed as this ultimate tool for solving obscure cases, right? So if you don't have a specialist, you just feed it into AI and it's better than not having anything look at it. Well, not the case, not even for PathChat. None of the models, not even the domain specialist PathChat, reach expert human levels on rare cancers. And the insight here is that neural networks are pattern recognition engines. So if a rare entity lacks a massive statistical cluster of training data, hello, these are rare cancers, so by definition, they're rare enough not to have a massive statistical cluster of training data. AI cannot reliably generalize its reasoning. So yeah, there are limits to the knowledge, and it's not an oracle. It's not an oracle. And also, this was super cool. And there was this concept of the illusion of certainty. The models manufactured certainty. What does that mean? So when you look at cases, and if you have written a pathology report, you know for sure. If you have read a pathology report, you will see that as well. A lot of, we call it hedging language. And the hedging language is not for legal purposes to hedge yourself from liability. It's expression of uncertainty, because you're looking at biological structures that may not have boundaries, may not be like super certain when you look at it, because it is the property of its biology. So especially in cancer diagnostics, what's happening with the tissue becomes abnormal from normal. So the closer it is to normal, the easier it is to recognize. The farther it is from normal, the more funky it looks, because the cells change their criteria of malignancy, of that the nuclei change. Then you have the de-differentiation of tissue. It basically like changes forms. And if it changes form a lot, then even a trained human observer may not be able to 100% say, oh, this is what it is. And that's what we do. We express the uncertainty with hedging language, with definitions, right? Whereas AI is trained to do binary calls. So PathChat predicted exactly 0 cases as in situ or uncertain. So there are different like codes for the level of uncertainty, and these 2 categories, in situ and uncertain, are the ones that express uncertainty. It aggressively forced binary nuance of human biology into every nuance of human biology into binary benign or malignant bucket. And this is how they are trained. I love that the paper is addressing this, because that's also what you evaluate the performance on. Or did it say benign or malignant? Because maybe if it says benign, then at some point pathologist doesn't have to look at it, or the case becomes deprioritized. And there was no uncertain category. The human gold standard, what I already alluded to, human experts comfortably navigate ambiguity utilizing the ICD-03 uncertain codes when biology defies strict categorization. AI is mathematically rewarded for definitive answers, lacking the self-awareness to express doubt. Sometimes I think that Claude is expressing doubt to me. They didn't do Claude. I don't know if Claude does that well with images. Maybe that was the reason. Sometimes when I ask Claude, it's like, I don't know, I was not trained. I cannot retrieve. Go and retrieve yourself. And I'm like, that's why I'm using AI, so that I don't have to crawl the internet. But sometimes I have to still. But I'm digressing. Let's do round 4. This was a very, I don't know if it was innovative. It was new to me to even ask yourself this question: does conversational memory build a richer clinical picture, or trap the AI in a cascading echo chamber of its own mistakes? And what they found in the paper is that we do have memory trap mistakes. What does that mean? If you have a query in a chat, and then like it's this interface, and they call it the interface trap and anchoring bias. So anchoring is the keyword here. Anchoring bias. So if a chat invents something at the beginning of the conversation, then it refers to itself as if this hallucination was true. So what they stated is that sequential chat user interface wasn't that great. Independent, clean user interface, where the chat wipes out its memory and doesn't refer to itself from the beginning of the chat, was more beneficial, because then independent evaluation prevents failure. So treating each query independently, wiping memory between questions, prevented late-stage failures, highlighting the hidden danger of intuitive chatbot interface in medicine, right? Intuitive is like you just chat with it and it remembers what you told the chat and what the chat told you. And that's the problem. If the chat remembers its hallucination, then it's going to be referring to it. And it's going to be cascading the error. And there was an actinic keratosis case where a slide image was presented. This is time. Then there was a hallucinated misdiagnosis. AI hallucinated something, and then a question was asked about the lesion, factual question regarding the lesion, regarding the real lesion of actinic keratosis. And I love this word, the chat rejected reality. Chat rejected reality. I love it. How often do you reject reality? I sometimes reject reality when I don't know when. Mostly with my kids. I want them to be compliant and different. And the reality is that they are not always compliant and they are their own people. So like me wishing them to be different is basically rejection of reality. It's what AI does when it invents. So that's like me. I invented this ideal picture of my kids and now I reject reality that they don't match this ideal picture. Yeah. So let's not reject reality. It makes things more difficult. So when later presented with multiple choice option containing the actual ground truth, both models refused to answer, deeming the factual question inapplicable, right? My kid defiant, it's inapplicable. How can my kid be defiant at school? Well, that's a rejection of reality. Okay, so both Gemini and GPT hallucinated a wildly incorrect diagnosis early in the chat thread. When later presented with multiple choice options containing the actual ground truth, both models refused to answer, deeming the factual question inapplicable. The takeaway here is that AI anchored so hard to its initial hallucination that it mathematically rejected contradictory reality. That is, you know what? Let's put it in red here, because here it was a test, right? In this case, it was a test and we tricked it, or tricked it. We tested it. We wanted to check this feature if it anchors, and it does. And we knew how we were testing and we knew what we were testing. This is just a testimony of, because we know if you have ever used any of them, ChatGPT being the most famous because it was the first one, you know that it can present you information with high confidence. It can be, if it's like grossly inaccurate in your area of expertise, you're going to recognize it, right? So it's always to be treated as a helper. But if it's outside of your domain and it's like semi-true, you may not recognize it. So that's why I like the ones that show you the references and you can see, okay, where is this reference? Is it from somebody's private Facebook page or is it from PubMed? I will trust the PubMed reference more, just to be cautious, because it's going to invent something and then defend its answer. So the verdict for these are copilots, and Microsoft calls its its model copilot, not autopilots. I love this. Not autopilots, my friends. And the next great leap in medical AI is not higher baseline accuracy, because PathChat did pretty well, right? It did as well as a non-expert. The next leap is the algorithmic capability to recognize ambiguity and explicitly hand control back to human expert. So let's say we have PathChat that is at the level of non-expert, and the gap, we're not going to force train it to be better as an expert, but we figure out a way for it to say, hey, this is in this uncertainty, this gap domain between expert knowledge and me. How about an expert looks at it? So that's our message to take home. Copilots, not autopilots. And important thing is to know your model's inherent calibration, overcaller versus undercaller. And I bet there's more nuances to that as we start testing them, as they become more prevalent. There's only one available PathChat that is domain specific. Maybe there's going to be more. Maybe as I speak, there are already more that are not publicly available. And then the other thing is beware of conversational interfaces that propagate anchoring bias. And oh my goodness, my trailblazers, there are so many sources of bias that when I read about them, I want to like switch off my computer. But I was talking to a colleague of mine, Dr. Candice Chu. She's a veterinary pathologist, highly involved in AI literacy, propagation, and basically promoting AI as a tool. She says a tool is a tool is a tool. It is a tool. Right? So like, don't throw away the tool, just learn how to use the tool. And if you're not comfortable using the tool for some tasks, just use something else for these tasks, but figure out what you're comfortable with using the tool for. And the third takeaway, true medical intelligence isn't just knowing the answer, it's knowing the limits of your own knowledge. Oh my goodness. That's also a tricky one. You don't always know the limits of your own knowledge. But I don't remember the 4 stages of learning stuff. First is like, you know, you don't know. Then you know a little bit. Then you think you know everything. And then you realize, I know something, but there's a lot I don't know. So that's like the 4th level. You have to reach the 4th level yourself. And what we are trying is to teach AI to basically recognize the gap that it has. And I bet there are computational methods to do that. I hope I can ask about these methods my future podcast guest, Francesco. If you're just starting your digital pathology journey, I have something for you. This book, Digital Pathology One-on-One, All You Need to Know to Start and Continue Your Digital Pathology Journey. This edition is the first edition, but you can get it for free. And let me show you where, on my website. When you get this, you're going to be on my mailing list, which means you will get the 2nd edition as soon as it's out. And the only thing that blocks me from giving it to you is images. I need to create new images. So there are like illustrations. I need to use, I want to show you some better illustration. My favorite illustration are the giraffes. Oh, here, the giraffes. Explaining computer vision concepts to non-computer scientists, which is something super important coming forward. The webinar that we held with Roche Diagnostics USA yesterday was talking about the changing role of a pathologist, where they will need to have some computer vision literacy. Maybe sometimes I'm going to stop myself from crying just yet, because what happens sometimes is the streaming software doesn't bring in the comments, and then I look at the recording and there was like this, that, from this country, and a lot of questions. So even if you're watching the recording, go ahead, comment, say hi. It's very heartwarming when I see live comments from you. Thank you so much for joining me. Go grab the book so that you can get the updated 2nd edition automatically. And I talk to you in the next episode.